Hey guys, here's Tuesday's video. You will need your global winds page for Tuesday, March 31st. I know some of the classes have already covered global winds, but again, we're going to review just to make sure that we've covered it. Okay, our I can statements for today are I can understand what winds are and how they're formed, and I can explain the different types of winds. So the first thing we're going to do is we're going to review the question, what is wind? And we're going to check out this video to see.
It comes at you as a breeze, as a gust, as a gale, or in the scariest of situations, a hurricane or tornado at speeds up to 400 kilometers an hour. Moving air can be as delightful as it can be frightening. But how does wind happen? Here's a one-sentence answer. Wind is caused by air flowing from an area of high pressure to an area of low pressure. The long answer is that...
Remember, yesterday we said winds will flow from high to low.
But there are a bunch of variables that affect wind formation, speed, and direction, including the sun and the Earth's rotation. Well, let's back it up a bit. The air that's all around you, it's made of nitrogen molecules, about 78%, oxygen molecules, about 21%, and water vapor, between 1 and 4%. When we talk about air pressure, we're talking about the amount of force that these molecules exert on a given area. When a mass of air warms, it rises and therefore exerts less pressure on the surface. And especially if that air is moist, that rising air can become unstable and create cloudy, rainy, even stormy conditions. That's why low pressure systems are often associated with bad weather. But that low you see on the weather map is only low in relation to the air around it. There's always a mass of cooler, drier air, usually coming in from a polar region, waiting to rush in, push that low out of the way, and sit right on top of the land. That's a high-pressure system, and when it dominates, clear skies usually come with it. So think of the wind as the atmosphere's eternally futile struggle to find a balance between these two competing systems. Air flows from a high-pressure to low-pressure systems to try to reach equilibrium, and in doing so, creates wind. The closer the high and low pressure areas are to each other, the stronger the wind. Now, unsurprisingly, the sun plays a big part in all of this, as it heats the surface of the Earth. About 2% of all the sun's energy that reaches our planet is eventually converted into wind energy, a small portion which we humans try to harness. The spin of our planet also plays an important role. If the Earth didn't rotate, global winds would pretty much blow in straight lines with cold air flowing from the poles, heating up at the equator and then going back again. But the Earth's rotation produces a force on everything that's moving relative to the Earth, including air masses, a phenomenon known as the Coriolis effect.
Okay, so go like this and say Coriolis effect. The Coriolis effect is what causes wind, instead of flowing just straight from the poles towards the equator and then back again, it causes everything to turn.
That rotation deflects the direction of the winds to the right in the northern hemisphere and to the left in the southern hemisphere. Put it together, and these forces can do amazing things. According to most sources, the highest surface wind speed ever recorded was at the top of Mount Washington in New Hampshire. Wind gusts during a particularly brutal storm in 1934 topped out at 372 kilometers per hour. But in 1996, instruments about 10 meters above the surface recorded winds of 408 kilometers per hour during Cyclone Olivia off the coast of Australia. If it's all the same to you, I'll just take my gentle fall breeze. Thank you very much. And thank you to all of our viewers, especially our subables.
So, what is wind? Wind is air in motion. It is produced by the uneven heating of the Earth's surface by the sun. And since the Earth's surface is made of various land and water formations, it absorbs the sun's rays differently, unevenly and at different rates, and it releases heat at different rates. Two factors are necessary to specify wind: the speed of the wind and the direction in which it's flowing. So what causes the wind to blow? As the sun warms the Earth's surface, the atmosphere warms too. Some parts of our Earth receive direct rays from the sun all year. That's near the equator. And they're always warm. Other places receive indirect rays, So the climate is colder, okay? Warm air, which weighs less than cold air, rises. And then the cool air moves in to replace the rising warm air. This movement of air is what makes the wind blow. So, at this point, you're going to need your 4 crayons or colored pencils or markers. You're going to need your blue, your red, your yellow, and your orange. Okay, and we're going to talk about global winds. Winds are named for where they come from, okay? Just like people are named for where they come from. My grandfather is from Italy, so we would say that he is Italian. Even though he grew up in the United States, he still considered himself Italian because that's where he came from. Winds are named from where they come from also. So we're going to be filling in our global winds page and talking about the names of different winds in different regions of the earth. So this is the page you're looking at today, okay? And the first one that we're going to talk about is going to be our Arctic, the polar region, the wind coming from the polar region. But before we do that, hang on just a second. There we go. Okay, so the uneven heating between the equator and the north and south poles is what causes global winds. So you see here a picture of the globe, okay? These are the rays of the sun. The sun's rays are directly hitting right here along the equator and in the tropics. So that's going to stay warm all year round. There's not going to be a whole lot of temperature change there, which also means there's not going to be a lot of heavy winds or strong winds near the equator because there's not a variance of temperature. Okay? Up at the North Pole, they have much more indirect rays, meaning that the sunlight does not hit in the same place at all times. Okay? So that difference in the rays of the sun and in the temperature is what is going to cause our global wind patterns. So as the sunlight strikes the Earth's curved surface near the equator, the concentrated sunlight heats the surface to a high temperature. The warm air rises, producing low pressure systems. In regions closer to the poles, the sunlight is more spread out. Because less of the sun's energy reaches these regions, the air above them is cooler and denser and therefore sinks and creates high pressure systems. And these set the global winds in motion. So, if the Earth didn't rotate, like we saw in the video, the winds would flow from the North Pole and the South Pole towards the equator, from areas of high pressure to areas of low pressure. And they would just go straight up, straight down, okay? However, because of the Coriolis effect and the Earth's rotation, those winds actually turn to the right in the northern hemisphere and to the left in the southern hemisphere. Okay? So because the Coriolis effect causes these global winds to curve, they cannot flow directly from the poles towards the equator. Instead, the global winds travel along 3 different routes in each hemisphere. Remember, hemisphere means half of the Earth. Okay? Hemi meaning half, sphere meaning a 3-dimensional circle. Hemisphere is half of that circle. Okay? So these routes, which can circle the world, are called global wind belts.